the object from the lens would be almost infinity. So what does it consist of? It again consists of an objective and an eyepiece, very similar to the compound microscope. But let us see how is this arrangement different here? In this case, if you see, it is just the opposite. In this case, the objective is larger and the eyepiece is smaller. So the objective has a larger focal length in this case, and the eyepiece has a smaller focal length. Why is the objective more powerful here? Because the object is far away here. So the objective has to be more powerful to catch the object because it is far away. Right? But in the previous case, the object was near, so the objective was small. So here the objective is large and the eyepiece is small. So the concept still remains the same. Here the object is at infinity, so two parallel rays are coming from the object placed at infinity. It forms an image B dash A dash, which is a real inverted image, and this image acts as an object for the eyepiece. And as a result, an image is formed. So in this case, the image formed by the objective is again a real and inverted image, and it is at the second focal point of the objective. So if you see here, this image is formed at the second focal point, that is the second focus. And the second focus is nothing but the second focus of the objective is the same as the first focus of the eyepiece in this case. So there is no concept of tube length here. Right? So this is how the image is formed in this case. Now let us look at the magnification of a telescope. So magnification in this case is equal to, if you look at it, so what would be the magnification? That is height of the image by height of the object, or we can also consider the visual angle. Right? So what is the visual angle or the angle subtended by the image on the eye? That is beta, and the angle subtended by the object on the eye, that is alpha. Right? So we can say that magnification is equal to beta divided by alpha. So again, looking at the figure, what is beta? If you look at this triangle, what is beta? Beta is nothing but h by fe. Again, what is alpha? If you look at this triangle, what is alpha? Alpha is again h divided by f naught. So now putting these values of beta and alpha, we can say that magnification of a telescope is equal to f naught by fe. So magnification depends only on the ratio of the focal lengths of the objective and the eyepiece. Now what is the tube length in this case? In case of a microscope, the tube length was the distance between the second focal point of objective and first focal point of eyepiece. In this case, the second focal point of objective and the first focal point of eyepiece lie at the same point. So here we say that we define tube length as focal length of eyepiece plus focal length of objective. This is defined as the tube length in this case. Right, so based on